Hello everyone, welcome on another episode of Introduction to Java. This time around we will be going through more of a specific guideline. So we will be following labs from the Malmö University. And more specifically, we will be starting with the sixth one. We will be starting with some for loops, some problem solving, and some quite well-known functions. I will be using IntelliJ locally, though we might change that afterwards if there are more people and we want to either collaborate or we want to be able to use the same platform for all. With all that in mind, I am going to be copying over the exercise to English first, and then showing how I go through the process of actually solving it. So, let's start with the first exercise. So we're gonna just say first exercise. And then we're gonna say for loop 1. And we are going to do what the for loop 1 is asking for. So that is integer numbers between 1 and 10 in ascending order. So if we are doing something with a lot of numbers in order, what do? We use a for loop. And we want this for loop to go from 1 to 10. So this means I starts at a 1. It increases by 1 every time. And it will stop when it is not less than 11. So 10 is less than 11. 11 is not less than 11. So we can now just print I and comma and the space, and then perhaps just a new line. Let's see what that looks like. And we are getting pretty much exactly what was asked of us. Only you can see I'm getting this extra comma at the end, which I don't like. So let's make this a tiny bit smarter. Let's have an if here that says if I is not 10, then I'm also printing comma and space. Otherwise, I'm printing out just a space. Or we don't even really need that because we do not need a space at the end. So let's see that again. Now that is much more like it. So for loop 1, 1 through 10. Let's get started on the for loop 2. So the for loop 2 is going to do the same, but with descending order. So for anyone unfamiliar, a for loop just has some very specific parts. It has what number it's gonna start with, when it should stop, and what it should do each iteration. So, if instead we go with starting at 10, going for as long as I is bigger than 0, as we do not care about 0, and decreasing by 1 each time, we're almost done. We only need this one, because at 1 we do not need another comma. And you can see that as soon as I run it, we're already done with the second loop. And indeed, that was it. I'm just gonna put another new line between each iteration, so they're more spaced out. Okay, the third one we want to do for every integer between 1 and 10 that are even. So even integers between 1 and 10 ascending. And we can start at 2, since this is the first one we need. We can stop just before 11. And we can increase by 2. Remember, this is just what is done after each iteration. And let's test it. And indeed, we go 2, 4, 6, 8, 10. Let's check the fourth one. So the fourth one is asking us for the odd integer numbers between 1 and 10 in descending order. So we are gonna start at 10, or rather at 9. Because we know that 10 is not one of them. We're gonna continue as long as we are bigger than 0. We're going to decrease by 2 each time. And we're going to do this as long as this is not a 1, which is the last one. And we're done. FYI, we could just follow the 10 instead of 9 and do this with another if. But here we go, 9, 7, 5, 3, 1. Yeah, it's visible. And for the fifth and final loop, they want even integer numbers between 1 and 100 in ascending order. Oh. They want, what are they called? Tens. Tens. Or decades? I'm not sure you can use that word. Anyway. But yeah. 10, 20, etc. So again, all we have to do is start at 10. While less than 110. Or 101. Plus equals 10. And the last one is the 100. And there we go. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The first exercise is done. The 1B is asking for the same thing, but in while loops. So let's try doing that very fast. So let's say we're starting with this. Or rather, we're gonna be converting it. So the first and last outs we don't care, we can keep. So we can have an int that is 1, int I, sorry. Remember, we can just copy this. Then we can say while I is less than 11. Then I do whatever I did. And the only difference is that I need to also increment whatever was at the end. So I++. And that's it. We have converted our first for loop into a while. Let's do the same for the rest. The only problem here is that we have set I outside the while loop. So now I exists, and we need to use the same elsewhere. So we just go I equals 10. We cannot reinitialize I. While I is more than 0. We do everything inside. And then we just decrement by 1. So exact same thing. I is 2. While I less than 11. Copy the insides. And then this. Second to last. I is 9. I is more than 0. Copy, paste, and then we decrease by 2. We set I to 10. We check that I is not more than Yeah. It's not more than 101. And we increase it by 10. Let's see if in me doing this fast I made any mistakes. Mary and Ari Harry, are you going to save this stream so I can watch it later? Yes, it's automatically saved here. Hey, thanks for the follow. It's gonna be saved here on Twitch, and I am going to upload it on the YouTube channel. By the way, can you hear me clearly? I'm always unsure when I have music on. Thanks for the follow, by the way. Perfect. Let me grab the YouTube link as well. Thanks for the follow, Sarkis. So yeah, I will also be posting it there as soon as I can. So it is more of a playlist. So people can just go through it easily. Oh, we should change the names. They're wireless now. While. There. Ta-da! Okay, and last thing is to do the same thing with a do while instead. The keen among you will see that it is basically the exact same thing. So do actually all of it. And then while. So if I is 11, it will stop. Oh, do. Let me just first fix those. Okay. And then let's see, what is the fastest way we can go about this? We can replace this with a do, or we can just first copy this, or cut this, and then say do. And then paste it here. And then semicolon. I think that's actually all we need to do. Though, since we are on the subject of doing this, might as well show one more thing. Hello, Sahan. Probably that's a name. Sahan. I'm sure I should not put the rest of the letters together. If you can help me pronounce the name, all the better. Has what we've been up to created any questions for you, Sahan? Because I'm about to do something a bit different. Cool. I'm gonna assume that means that there is no question. So instead of doing the plus plus here, I can get rid of that and put it here. So for anyone that doesn't know about this, I'm done with all labs, just came to see what's going on. Oh, cool. Do you know about this? I++ versus ++I? Let me go grab some water while you think about it. So do we have any answers? I'm gonna take that as a no. So I++ and ++I both increase I by 1. Yes. So they're basically a shorter way of saying this, which is in itself a shorter way of saying this. But I++ means that if you're trying to determine something, like if I is less than 11, it will first try to do that determination and then raise I by 1. Whereas if you have ++ before the I, it will first increase I by 1 and then make that determination. So here I starts as 1. When this is trying to make the determination if I is less than 11, it will be checking for 2. But if it was written like this, it would be checking for 1, and then I would change to 2. It might seem a bit confusing at first, but it helps us write much more easily readable code. Sometimes saving space does help with readability. Other times it might create more confusion. So if it is not clear to you, do not use it. Thanks for the follow, Sahan. Control X. Huh. I do not believe we could do that here. No. Okay. Yeah. Too bad. I really like playing code golf sometimes. Do. And there we go. That should be all the do whiles. Is it okay to share your profile with my friend on Twitter? Yeah, of course. This is not specifically from university. As you can see all around, the partnerships to this are Spelens, Studiefrämjandet, and Sverok. So we can see that all our loops are still working as they should be. And we're good to continue. The only thing I'm using from university is these labs, which I got the okay from the teachers. Because I thought they could help you guys from the program. So this is going from a file that is given on Canvas. Okay, So go from outputting one thing to outputting the same thing a few times. So I'm just gonna do it on my own here, very fast. So let's go second exercise. Thanks for the follow, Ramor. Let's say we have an array. And let's say that array is 10, 13, 16, 19, 22, and 25. Then you can imagine that we could very easily output it. Remember that arrays in Java are 0 indexed, so we need to start at a 0. Then we continue for its length, so how many elements are in there. And we increment the index by 1. And we can just system out the element, so Ri, and a space afterwards. That should look pretty enough. So this will give us a one line of that array. If we want that 3 times, what could we do? Easiest thing that we could do is just create another for loop. Let's just put a new line afterwards. It's always a good idea when you are doing a single line. So we want to do it 3 times. So let's start at 0 and while less than 3. So this will go 0, 1, 2 and increment by 1. And let's cut all of that in there. So we'll be doing that 3 times. And we're done. Thank you for the follow, Official Revi. As you can see, we did indeed get 3 times the same thing. So, third one. I'm not going to go get the original files because I don't see it as really necessary. But this is basically just a multiplication table. So let's create a multiplication table. So we will be going, let's say which numbers multiplication table are we making? So let's say our number is 3, as is shown here. And the multiplication table is, by definition, all the numbers from 1 to 10 times that number. So less than 11 and I++. Obviously, we could just say less than or equal to 10. It's just more common practice to do the under less. And I think it's slightly faster for a computer. Let's go. So we will be printing one line. So let's do south. I, because 1, 2, 3, etc. Then I'm not gonna follow it exactly the same. I'm gonna make it a bit easier on the eyes for me. So I'm going to put here a space, then the asterisk, then a space, then our number, and then space equals space, and then I times that number. There we go. And just for good measure, as said before, I like just putting another space at new line at the end. And you can see how we now get this very nice multiplication table. And we could very easily change it because I used a parameter here, or rather a variable. If I just change this to 7, then all of a sudden, with no other changes, I have the multiplication table of 7. Create a program, and the user can choose their own number. So yeah. Let's make this a bit nicer. Let's go with all of them. Let's go with like from 1 to 10. So that would be another for loop. Number. That's gonna start at a 1. That is going to continue until 10. That is going to increase by 1. So if I just put that in there, and let's say that we start by saying this is salt multiplication table of num. What's the program you code in? I am currently coding in IntelliJ by JetBrains. They have their program normally costs quite a bit, but you can get it for free as a student. So as long as you're a student, you can get it for free. Not forever, only for as long as you're a student, or within a year or so. I do not particularly like it, but it is recommended by the university I'm in, so I thought I might as well. Like even just using Atom and or whatever code editor you want, and then compiling from the terminal is not such a big deal, and it does help with learning the basics a lot better. But yeah. Also, NetBeans and Eclipse are very widely used for Java. Zodiac, there is also VS Code, yeah, and Visual Studio Community Edition. VS Code I wholeheartedly recommend for pretty much anything. Visual Studio Community Edition is very much so a larger thing. So VS Code is more attuned to Atom with a lot more flexibility. Visual Studio Code is really, really good if you're writing C# or C++, and its debugger is second to none. Okay, so multiplication table of numbers 1 through 10, and actually we should be done. Look, let me just put like stars here or something. And of course, this is a matter of personal preference, so you might as well try them. So yeah, in 1, 2, 3, 4, 5, 6, 7 lines of code, we have the multiplication table of 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe we went well beyond 3B. And now we want to be creating these amazing pyramids. Let's see. So we go from 1 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fourth exercise. For when we are doing nested loops, we usually go with either a very descriptive name for our variables or ij. I for the outer, j for the inner, especially when we're talking matrices. So each row will be I, its column will be j. Let's start a 1. Nah, it doesn't really matter. And is it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. I less than 10. I plus plus. And then at max, we want the same. So J. Now that's a nicer song. Or rather, more uplifting. Say less than 10. And then let's print. Sorry. Wrong language in mind. Print 1 asterisk for each one. And after we're done with the inner loop, oh wait, this should continue not until 10, but until I, because we want the first loop to run for 1, the second one for 2, the third one for 3, etc. And then we want to go to a new line. Let's see, and this should be I. Salt for A. And indeed, we got the exact same result. Can't make it exactly as big as it should be. I think that's there. Anyway, now let's flip it upside down. So we want to instead do this for j minus I times, or wait, let's start this at 10. Just trying to think how it would make more sense. Okay. So then while j is smaller than I, it will keep continuing. Yeah. Yeah, I think that's just it. Let's see. Indeed. There we go. Can't really scroll exactly all the way. Ah, there we go. So in order to do C, all we need to do is do the same thing up until half minus 1, then do 1 normal, and then shift to the other one. So this is 4. Again, I'm just going with the easiest thing that comes to mind, and that is easy to think about. So 4. And this will create those. And after we're done with that, we can just salt 5 asterisks. And then we can flip it over. Start at A4. And go with a minus minus. Yep. Oh, wait. I missed one on the first one. Yes. Okay. There we are. And then a tree. Let's create a tree, shall we? So this is more of a symmetric thing. Let's think about it a bit. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6. Let's look at it visually. So this is 4D. And this would look something like so. We said 9 by 6. So this would be something like 4, 1. And let me copy this. Yeah. So we would be adding those per line. Why is it complaining? Anyway, I just want to see what it looks like anyway. Comma. Okay, so first time we are skipping. The height is 6. So height minus 2. Okay. Height 6. Width is 9. Last check. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Yes. So int skip was 1, 2, 3, 4. And then it is minus 1 per turn. Yeah. Yeah, I think we can work with this. Let's see. So for I less than height, I plus plus. For J, as I said, when we don't have something more specific, I and J work just fine. J less than width. Let's have a current skip. Hey, DKR Grim, thanks for the follow. Int car skip is skip. let's say this will fix the first problem. We still need the following: L and plus plus, J plus plus. Okay. So if current skip is not 0, then current skip minus minus. Otherwise, we will be printing no new line. This is an extra assignment for anyone watching from the program. Okay, so we have skipped, in this case, 4 steps. Hooray. But then we hit 0, and we printed this. So how will we continue? Oh, it is 0, so we will continue printing. Great, that is not what we want. Then we should have skip again. Based on what? We could override the original skip. Couldn't we? Yeah, we could. The skip should fall by 1 after each iteration of this. So outside of this, skip minus minus. Otherwise, while in here, current skip wait. We shouldn't reset current skip there. No. We want to do that if skip plus J. So this skip would be 3. Plus 3 is 6. If skip plus of no. Okay, let us just see it. Like, this is wrong, but let's just see it. Wow, this is wrong. Oh, that's why. Salt. Okay. Fair enough. Can't see it due to the banner on your stream. Yeah, I keep zooming in and showing it off. But as I said, like, I know that this is wrong. We are ignoring a few things. So let's take a closer look. Current skip is skip, and we're starting at A4, which is basically just a... Yeah, let's make it even more specific. Width divided by 2. So this is 4 currently. And if we are skipping before printing, we could check for how many we should print. Oh, plus we should instead be printing spaces. Duh. System out print. Gör en for loop som skriver ut to my... Yeah, exactly. I forgot to do space. Två nästländer som skriver ut. Yeah. As I said, I forgot to do a space. But other than that, I'm still missing the writing the rest of them, which means I should either consider keeping track of how many I should print, or somehow reiterate how many I should skip instead. Let's see how much this fixes. Yeah. So as expected, it fixes the left part, not the right part. So if j plus current skip, no, plus skip. So if we are at, this is 5 plus 4 is 9. Wait, what? Could you explain what arrays are and how they function? Dear Ebra. Wait. One moment, there are a few people that wrote at the same time. Superbot left. Which of one are you? I'm currently doing D. Could you explain arrays? Yes, let's explain arrays. If you don't know arrays, this is a bit completely out of grounds. So an array is just a few of the same variable. So if we are talking integers and we have an A, we can give it one value. That value can be 1, 2, 3, doesn't matter, but it needs to be some one value of an integer. If instead we have an array, then we can have many values of integers. So 1, 2, 3, something. Then the way that you address the different places inside the array is with the bracket notation. So this will be 0 if you're talking about the first one, 1 if you're talking about the second one, 2 if you're talking about the third one, and so on. That is because the number here just indicates how many ints afterwards it should look for. So when you say 0 here, it just means that, oh, remember that this is basically just pointing to the memory where the data is located. So it is saying just, hey, I want whatever is in there, 0 spaces after it starts. Whereas when you say 1, you're asking for what is one integer afterwards. So after the first integer is the second integer. Is that clear enough, Moe? So if we're skipping 3 and 5. Wait, I'm just gonna shout it. Skip plus J is skip plus J. Perfect. Okay, so skip plus J was 4. Then it was 5. Oh, that's... was it? I want it to stop when... Wait. But how do they work in nested selections and iterations? You're thinking of 2D arrays. So remember how we talked about an array being a few of the same thing together? So 1, 2, 3, 4, etc. An array can be an array of another array. So I could just, instead of having just some ints here, have an array of ints in there. Let me just... There. So suddenly, each element of our array R is another int array. So now, when I am addressing this, I need to say, hey, I want your first array in there, and I want the second element of that array. So if I had a for loop, we want to go for as many rows as it has, so that is how many arrays are in there. So r.length, which in this case is 2. And then we want to go for each column that there is in there, which is how many elements each array has. So we can take just the first one, or more specifically the ith one, though they should all have the same length. And now Rij is talking about that specific one. Is that clear, Mo? No problem. Okay. 4, 5, 6, 7, 8. Let's try just doing a very bad idea instead. If j plus skip is 4 plus 5, right? No, 4 plus 4 is 8. 8, then car skip is skip. Yeah, I can totally understand that. That is why I always try to explain arrays as clearly as possible and as completely as possible. Yay! The power of experience. So, how did we end up in that conclusion? As you can probably see, I skipped a lot of steps just because my muscle memory just remembers. So what went through my head? We are skipping for as many as skip. We want to stop skipping by some point. That point shifts by 1 each time. So one of the ways that you can figure that out is by testing. So my idea was I would see how much the slant is off and then change it from there. But I got it correct on the first one. Why? Because I imagined when does this one appear? this one doesn't have an extra one. So I know that I should only leave that one up here. So that is when we have an I of 4. A j of 4. So 4 plus skip, which starts at a 4, is an 8. So when that is an 8, we say that we should skip another that many. To be fair, we could even make this into just a break, because we do not need to print anything more. We do not need to try and see if this will work. As you can see, we get the exact same result. Feedback for your stream: either make your banner picture smaller or extend your stream window with a black border so the Spelens and Studiefrämjandet isn't blocking things. I will look into it. I wasn't the one that made the banner because I really don't know how to and haven't bothered into learning. But yeah, I will look into it. I'm not sure that I could shrink the window, unfortunately. I'm already using an ultra wide, so at the very least, most of the stuff are by definition out of your view window, because everything is set, to try and be in the middle of the screen. But please feel free to tell me if at any given point something is out of view. Making it smaller, though. The Studiefrämjandet surely should have been made a bit smaller. It's like by far the biggest. I will definitely look into it though, Testarius, thank you. Yeah, you can resize anything, but if I resize my screen, you won't be able to see anything. Like, I'm already streaming at 720p for a 3440 by 1440, yes. So that is half, basically. So everything's already stretched out. After becoming a partner, I should be able to try at least 1080p, though I'm guessing I'm gonna run out on my laptop, which is already at 100% CPU doing this. So that is unfortunately something that will be doable after I upgrade. So that is why I'm more considering the banner part. I've even considered trying to do standard ratio, 16:9, instead of, how much is mine? Is it 2:1? I don't think it's 2:1. I think it's slightly less. 3440 by 1440. 2.3. Oof. Slightly more, actually. Yeah. Really good for productivity. Quite a bit weird if other people don't have it, which most people don't. Anyway, reverting it back to the one that explains a little bit better what is happening. And then after we're done with this, we should do the original skip. Int original skip is width divided by 2, which is 4, and then make this original skip because we will be changing it. And then for is it 21:9? Let's see. Yep, I think that's the same. 40. Not quite. Maybe 22 by 9? Nope. I guess ultra wide is not defined by 9. It's this. Slightly less than 4K. Original skip. I plus people. System out. Just printing the spaces. Nothing to see here. Just so I can then print the final star. Wow, what the... I think I ended up with one too many system outs there. Yeah, I guess there. No? Wait, what? If, else, if... Feels off. Huh. I am not gonna pursue this further. We've already done way too much time on nothing important. Sorry for the tangent. Fifth exercise. Going from Celsius to Fahrenheit. I'm going to be using something a tiny bit more advanced, which is using a freaking method slash function. To Fahrenheit. And it's gonna take in Celsius. Is anyone here familiar with what the parameter is? A bit. Okay. So should I assume that I do not need to explain it, or should probably go ahead and explain it anyhow? Not for you, just for other people that might not know. Anyway, I'm just joking. I have talked about it in the last video, but we can do a quick refresher here as well. So, a function has a few key parts. It has a return type. So, as you can see, the main has usually, in Java at least, a void, which means it does not return something. This keyword that says public, private, or protected, which means who can call this specific function or method. Its name, so what does someone call this method? And finally, what can be found inside the parenthesis here. Those are called parameters. Different parameters are distinguished by commas. So if I want another parameter, I just put a comma, type, and another name. So parameter is something that is required when trying to call on a method. So in order for me to call on this method, I need to make it static because we are currently not creating an object. We talked about this in the last video as well. In case you haven't seen it, you can see it either on VOD here on Twitch or over on the YouTube channel. So, if I want to system out print line int cells, no, let me rephrase that. We will just output the result. So to Fahrenheit, and what is 30 degrees Celsius? I know, amazing, Sweden, 30 degrees Celsius, what are you talking about? You know, other countries exist and 30 degrees Celsius is not that uncommon. Never mind that we have like 10 currently. Let's see, how many degrees do we currently have? We have 11 degrees Celsius. Wow. We're gonna be toasted alive. Yeah. Let's see what 30 degrees Celsius means in Fahrenheit. So it is 86 degrees. Good to know. So 2 Fahrenheit takes in a parameter. You can see that IntelliJ picks it up automatically that we are talking about its Celsius parameter. And if I try to write here something like 30, which is a string instead of an integer or a double, I get an error saying that provided string required double. So parameter is a requirement of something that we want in order to continue on with our work. So in this case, it needs a double. Remember that an int can be converted into a double with 0 losses. So this is also the same. Furthermore, I can just say Celsius. This Celsius has nothing to do with that Celsius. It just so happens that they have the same name. But its value is what is transferred over. If I named this Orpheus, this is completely fine. The only requirement is that the type matches. Nothing more. Okay. Create a file that converts between Celsius and Fahrenheit. Okay, let's have some fun. Let's go from 10 to 20 and go from there. So let's do a shout Celsius to Fahrenheit. And then if we're doing a lot of stuff, we want a for loop. And we're gonna call this Celsius just because it makes sense. We're gonna start it at a 10. We're going to continue until 100 basically. And we're going to increase it by 10. So, we can system out, print Celsius, and then space this, and then to Fahrenheit, Celsius. So actually this can be a new line. There. And as you can see, we are getting the same result. Only difference is that because I said that Celsius is an int, we're not getting the 0.0. So click. There we go. Basically going from Fahrenheit to Celsius, so I will instead just do another function here called to Celsius. And this one takes in a Fahrenheit. And it is Fahrenheit. Hello, thank you. Minus 32 multiplied by 5 and divided by 9. And let's start it at a 50 and increase it by 20 and call this Fahrenheit just for convenience sake. Oi, Control Shift G, Control C, Control B, Celsius. Okay, so we'll be going from Fahrenheit to Celsius, and we're going to be continuing until 210-ish. There, sounds good. It's not gonna be the exact same, but you get the gist. So yeah, 50 Fahrenheit is 10, 70 is 21 point something, 90 is 32 point something, and we're getting to boiling. Sixth one. Factorial. Interesting. Interesting. Okay. I am going to do this in two ways. One is the way that most beginners would think about it, and the other is going to be the way that it is supposed to be done. And I don't think we will be able to go further than Lab 6 today, unfortunately, because I've been going through in very much detail of everything. So that's a shame. 6 exercise, but I hope you get something out of it. Okay, so what is this notation? So for any given number, n factorial is supposed to be not 1 times 2 times whatever times n. So three factorial is the same thing as 1 times 2 times 3. Thanks a lot. Let us know when you're gonna do the other later. Yeah, I will. It's just that I didn't expect this to take this long. And I believe it was a few people that wanted Lab 6. Let me double check it, just to be certain. Yeah, most people wanted Lab 6, so I think it's better that we explain it to the ground and then go from there. Okay, so the way most people would think about it, and it's completely normal, is that you would take, let's say, a int result and start it at 1, I'm guessing, and then have a for loop that starts at a 1, and then it goes up to n plus 1, so it goes up to n. We haven't said what n is. Int n is, let's say, 4. Factorial. And then they would say that result is equal to result times I. And that is indeed correct. South n plus exclamation is equal to... I'm not gonna write the in-betweens, I'm sorry. Result. I have explained it, so... So 4 factorial is 24, as we can see from here as well. But, and this is a big one, what if I told you there is a better way for calculating this? So, int or public int or static int recursive factorial. Okay, public, anyone can call it. Static, we do not need an object of our class in order to call this. Int, this method will be returning an integer. Recursive, this method will be calling itself. Factorial, the mathematical concept that we talked about. Okay, so recursive? Why would the method call itself? Well, that can be a very powerful tool. So in this case, let's say you want to know the factorial of 4. And you know that the factorial is 1 times 2 times whatever times n. Another way of thinking about that is going from whatever n is to 1. So this could just return 1 times whatever that was. So let's say if, and this is called the base case, if n is 1, return 1. We are done. Otherwise, footnote upon a footnote. When there is only one command that is to be run with an if or an else, then and only then it is okay to omit curly brackets. Much better to use them all the time otherwise, if that is too confusing for you. Otherwise, return recursive of n minus 1 times n. So whatever they gave us times whatever the previous one was. By the way, obviously I do not need these either, so let's make this a tiny bit more tidy. And just so we're clear, let's see that it actually works. So we do not need the for loop, we do not need anything. We can just go recursive factorial n. And you can see that we are getting the exact same result. Let me go through it one more time, even though you are able to just go back in the video. A recursive method is one that calls itself again. In this case, right here. A recursive method needs a base case, or a case where it will just return no matter what. I am saying that is 1 because I know that I'm starting at an integer. An integer cannot start at a 0.5. That said, I am not currently checking for a negative number, which would break this. So if I start with a -5 here, which is not something you do for a factorial, this will break. So we should ideally account for that. So if n is less than 0, return -1. And then we would say that, hey, you know, if there is an error, returns -1. The change I did there is because the factorial of 0, I believe, is 1. Let us check that. Factorial 0. Yeah. By definition only, factorial of 0 is 1. So we should be able to account for 0. This will run 1 times too many, but sue me. The factorial of 5 is, I believe, 125. No, 120? Yeah, it should be 120. Yeah. So yeah, it works. Write a program with 2 nesting for loops, which writes out the matrix blah blah. We've basically done this, the multiplication table. It's literally the multiplication table with less information. Same thing, but with less from the table. So again, not doing that. Guess the number. Okay. 8th exercise. Check the guess the number. Write an if case, and if it is smaller or bigger or whatever. Okay. Okay. You should be able to transfer between for, while, and do while through the previous exercises we looked into. Let's create a game. Let's create a guessing game. So first things first, we need a random number. Int rand int is random. Let's see. Import java dot. Where is random? Is it under util? Nope. Okay. Let me look that up real quick. Java random int. Come on. Please and thank you. Oh, is it built in? Is it just random with capital R? So it is. And it is at the... Yeah. Just remember, Amor, try to not import everything. The wild card means everything under there. The status, it seems it is actually under util. And probably there is also one under math. But we first need an object, so let's create one. Yeah, no problem. It will just load your program with a lot of extra stuff that you don't need. RNG. Let's call this RNGesus. Or RNGesus. There we go. And then let's take a random number to be RNGesus dot... Wait. Yes. Is it just ints? Next int. RNGesus next int. Maximum and minimum. Are they required? I don't believe so. Nah, we'll just leave it like that. And let's just run it a couple of times to see what it's like. Yeah, that sounds like a plan. Like, maybe it is way too big as it is. Oh. What is the problem here? Company main. Hello. Are you missing the packet statement? Please wake up. Does the import need to come after the packets? Java util random. There we go. Yes, the numbers are way too big. Okay. Okay, let's put it into context then. Int n there max min. Okay, and then we can do int random RND. Number is RNGesus. Next int modulo n. No, modulo n plus. Huh? No, plus. What? No, that's odd. That's not how that works. Wait. There must be a better way than this. There. I'm not gonna go insane for this. Okay. Let's see what it looks like. It should be lower than 1200. Yep. Let's bound it a bit more to 100 and then let's take a number from the user. Scanner input is new scanner. In case you've missed the memo, if you're using it in some lab, a scanner that is static, please create a new one. Thank you. And then Boolean run true for again while run. If possible, do while, don't do while. System out print tell us your guess. Beep boop. And then int guess is input next int. If guess is random number, south boop beep. South, you're amazing. Run is false. Else, if guess lower than RND, south go higher, else south go lower. Let's test this. Eighth exercise. Beep boop. Tell us your guess. So here we can talk about one more thing. Binary search. Making sure that you get rid of half of the results each time you're searching for something. So we know that we are looking for a number between 1 and 100. So I'm gonna say 50. Go higher, beep boop. So we now know it's something between 50 and 100. So I'm gonna go 75. Go higher, beep boop. So the next step is 82.5, so I'm gonna go 83. Go higher, beep boop, for... Did I not change it? I did change it to 100. How high did it go? Let's go with 91. Go higher. Now I am confused. Okay, sure. Let's go with 95. Go higher. 100. Go lower. Wow. Go lower. It's 96. Wow. Sorry. It's just out of reach. But yeah, it's gonna be 96. Beep boop, tell us your guess. Guess input. Guess is a number. Why didn't I not... Oh, there we go. Okay, it didn't take the enter. Boop beep, you're amazing. Okay. So the ninth one is a game. Which game? Oh, it's exactly what we just did. So this was 8th and 9, I guess. And then the 10th and final one. Go from pseudocode for reception. Ah, yes. Okay. So in this one, you are at the receptionist desk and you are creating their program for their customers. So let's say that there are 3 possibilities for them. Tenth exercise. Or let's give it the name. Reception desk. And let's start with an array of what we offer. So offer is and we have cleanup for 50 bucks. And we have hole filling, which is 150 bucks. And we have full checkup. That is 200 bucks. So we're gonna start by outputting that information. Offers length. In this specific case, I will not be doing a second loop there, but that's because we only have 2 elements to each array. So I'm going to instead go offers or south here are our offers. Please choose what you need. And I'm going to say south offers I0. And then I'm going to put a tab. And then I'm going to say offers I1. And then the same thing. No, what did I do there? And then that will be done for each one of them. So let's just see that. Yeah. So 50, 150, 200. I would take that out and put that there. And then perhaps output the I as well. So we are talking about I plus 1. There. So now it should be a tiny bit more pleasing to the eye. Yeah, that looks more like it. Let's put some buts there as well. Okay. And then maybe they want more than one thing. So let's create a sum. Double sum is 0. And then let's also give them the option to stop. South for to get your total. And then let's put this in a run loop. So boolean run true while run if we need to system out print input your choice scanner input. Did we have that? No, we've deleted it. Input is equals new scanner system in and int choice is input dot next int. If choice is 4, run is false. Else if choice is 1. Then the sum will be increased by double dot parse double. So this takes in a string and outputs it as a double. So we know that offers of, it doesn't matter. So let's take, or rather it does, the choice. And we are at choice -1 because we are 0 indexed. And we're taking the second box there. And the same thing. So same thing for 2 and 3. 2, 3. Oh, right. So it's the exact same because we have the choice. So we can say if choice bigger than 0 and choice smaller than 4. So that is 1, 2, 3. Otherwise, shout this is not a valid choice. And then let's shout the total. Shout your total comes up to sum. Okay, so let's start with a cleanup. Let us add a choice of hole filling, full checkup. So that should be already 400, and then let's add the hole filling too, another hole filling rather. So that's 550, and then let's say that's enough. So yeah, we got 550. If we run this again and give it a random number like 5, we get this is not a valid choice. Here's actually, let's look into this. Rerun, stop and rerun. I wonder if IntelliJ follows what I expect it to. 5. Yeah. So when instead of system out, you do system air, the color changes. IntelliJ uses this deep red. Most others will use a more bright red. Hey! Thanks for the follow, Omuri. And let's finish this off with a limit for getting some kind of discount. After I found my mouse, there we go. Double discount limit. Let's say that 300 is a reasonable amount. So if sum is more or equal to discount limit, then shout, hey, you got a discount. Of sum times double discount, let's say 10% discount. It's completely fine to leave it there. It's still part of the if, but I like it on the same line, usually. And else shout, you did not get any discount. I want to put dollars at the end. I'm sorry. Okay. And your total comes up to... wait. Let's update the sum here. Sum is sum times 1 minus discount. So this will give us 90% to multiply. So it will drop by 10%. Okay, I think that's it. Let's give it a run. Let's just take whole filling and full checkup. So that's $350. So we should get $35 off. Yep. Hey, you got a discount of $35. Your total comes up to $315. Okay, so this has been more or less all of Lab 6, which is a tiny bit of problem solving and a lot of loops. So hopefully this should enlighten you on how to effectively use loops and give you some insight into arrays and 2D arrays. Thanks for sticking with me. Have a great day.